Right-angle trig ratios, it's important to understand that those ratios are about sides. And so in this problem, when it says find all 6 trigonometric ratios for angle C, they're asking us to write out the trig ratios that come from this mnemonic device of so, ca, and then to, And sometimes you'll see teachers put in like little slashes so you can keep them all apart. And so in this problem, they're asking us to do it for angle C only. Now, that being said, we could call that theta, as I had mentioned before, but we're just going to keep it with C. So sine of angle C is equal to the ratio of the opposite side to the hypotenuse side. And so sometimes it helps to draw arrows. So we come to angle C right here, and we draw an arrow, and we find that the opposite is 8, but then the hypotenuse side, it's not defined. So we're going to use the Pythagorean Theorem. We've used that many times before, so let's just write that out as you know it. You probably know it as a squared plus b squared is equal to c squared. Now, I purposely did this so that the hypotenuse was across from a letter other than c. This is typically how it's taught in middle school, but it probably would be better to teach it as side 1 squared plus side 2 squared equals hypotenuse squared, because in this problem, hypotenuse is a. And you don't have to rewrite it as long as you realize that a and b mean the sides. So like a is 4 and b is 8, and c means hypotenuse, even though technically in this problem it's actually a. So 4 squared is 16. Plus 64, sorry about that. So 16 plus 64 is equal to c squared. And of course, 16 plus 64 is 80. And then to finish this problem off, we take the square root. Now, in trigonometry, we don't take a negative square root at this point. There is actually a place for that. It's just not with right angle trig because we don't have a point of reference for that. So we have the square root of 80, which of course needs to be broken down using a prime factor tree, just like you learned when you took the square root in Algebra 2. There is a lot of algebra, okay, in trigonometry. It does exist everywhere, so you never get away from it, and you use it all the time in little problems like that. So 80 is 2 times 40. It's a badly written 40, and then that's 2 times 20. Which is 2 times 10, and so on. So we're going to pull out these common 2's, these pairs, and we're going to root the 5. So the hypotenuse is equal to 4, 2 times 2, square root of 5. And so now that I know my hypotenuse value, I can now come back and actually complete this ratio. This ratio was opposite 8 divided by the hypotenuse, which was found to be 4 root 5. All right, and so that one took a long time because we had to find the hypotenuse, but now we can do the other ones very easily. And I'll come back and reduce these at the end. I know that needs to be reduced. So cosine would be adjacent over hypotenuse, which would be, now be careful, right? Because the hypotenuse is 4 root 5, and some students will get really confused because they'll say, isn't that adjacent? The adjacent is what's not the hypotenuse. So the adjacent is actually here, right, next to C. I know that this is also next to it, but it's the hypotenuse, so it can't be both. So next to C is 4, and then the hypotenuse is 4 root 5. And then we have our tangent, of course, right? Our tangent of C is going to be opposite over hypotenuse. Sorry, over adjacent. Remember, tangent has no hypotenuse, so tangent is opposite over adjacent. It's the only one that doesn't have the hypotenuse, which is very useful in the real world. So opposite over adjacent would be 8 over 4, okay, and then we reduce them. But I wanted to leave them like this so you could see just very easily opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. So to reduce this, we're first going to reduce the integer portion, so we get 2 over root 5. Here we'll get 1 over root 5, and here we'll get 2. And then we're going to remember some other things from algebra, like we can't have square roots on the bottom, so we have to rationalize by multiplying by that square root on the top and the bottom. And that's just a grammatical math thing that we have to do throughout all of mathematics, algebra, geometry, trigonometry, and calculus. So this will come out to 2 root 5 divided by the square root of 25, which is 5. this will come out to root 5 over the square root of 25, which is 5. And of course, that one doesn't reduce. So it does ask for the 6 trig ratios. So there are 3 more of them. And there is no, again, there's no mnemonic device for them. And I never actually find cosecant, secant, or tangent directly. I always find their corresponding reciprocal identity, and then I reciprocate it. But be careful about doing that. You don't really want to go all the way back to here and go hypotenuse over opposite is root 4 root 5 over 8. It's already reduced, but you don't want to pick this part. You want to reciprocate this before you rationalized. And the reason is if you reciprocate the rationalized version, you'll have to rationalize again. But if I reciprocate this, which is equivalent to that, I'll just get root 5 over 2. Don't have to rationalize. If I reciprocate this, I just get root 5 over 1. And of course, the 2, if you reciprocate, you just get a half. But you can see how that's a major time saver of duplicating work. So this is the answer. But when you reciprocate it to find cosecant, you want to go back to the unrationalized version so you don't have to rationalize again. So what is the point of all this? These are all ratios, and these ratios are all defining what C is using different names, right? Sine is giving me this value, cosine is giving me that value, and tangent is giving me that value. Now, that being said, if you type them all into the calculator using the inverse, because remember, this is finding side ratios, but the inverse is going to find angles. You can see that if I type in inverse sine of this ratio, I get 63.435 degrees. Same thing with cosine's ratio and tangent. So they're all describing the same angle. They're just describing them using a different ratio of sides to other sides. And you can also do this on Desmos. By the way, don't forget this has to be in degree mode. So if you type this into a Casio or a TI or whatever you have, make sure this is done in degree mode. There is something called radian mode, which you want to avoid. So you want to go to mode and then change the mode to degree. And you have to do the same thing on Desmos. If you come over to Desmos, the mode is right here. You're going to put it on degree mode. If it's on radian, you want it to say degree. So to do that, to put this in, put in sine inverse, we go to function and then put in inverse sine. And then we have to go back to the main to type in what we want to. So 2 square root of 5. Oops, I put fifth root on accident. Square root of 5. Then highlight the whole thing and divide by 5. And you can see, look, I get the exact same answer that I got on the calculator, 63.435 degrees. But if you don't want to use the function, remember, you can just use arc, right? Arc sine. That is the same thing. This is one of those times where there's 2 ways to write the answer. This is just easier, so people will write the -1. But this function is actually called arc sine. So this is like a shorthand notation. This is the actual function. But using something like Desmos, it might just be easier to type in arc sine rather than having to find it in the function. I don't know. It's kind of up to you. But anyway, I sometimes will just type in arc sine. Notice I get the same thing. And obviously, if I wanted to type in arc cosine or arc tangent, I would get, as long as I use their ratio, I'd get the same angle measure.